Good morning and welcome to Introductory Logic, Lesson 14. And today we are talking about contradiction. Now we have been discussing categorical statements, standard categorical statements, and how to translate common conversation statements into the proper form so we can start looking at their truth values and compare them with other statements to see if arguments are valid or not. So we have already done that. Now we've moved into the square of opposition, which was our last lesson. So if you need to review that or learn what that is, those are in the last previous lessons. You can go back and look at those. But today we're going to start looking at the relationships between the statements that go on the square of opposition. Now this is blank right now. We're going to fill it in. But there's statements that go on each of these corners, and they have relationship with one another. There are four of them, and I have them listed here. They are contradiction, contrariety, subcontrariety, subimplication. Nope, I was right. There are five, and I forgot one. Subimplication and superimplication. We are going to be looking at each of these one at a time. Today, we're looking at contradiction. All right, so contradiction is if and only if the statements always have opposite truth values. And what this means is they cannot both be true and they cannot both be false. Now, again, as we said, the statements that we're looking at on the square of opposition, they have the same subject and the same predicate. So we are going to use the practice statement that we used in the last video with the policemen eat donuts. We're going to use the same one here. So before we get started, I'm going to go ahead and fill in everything we know about the square of opposition first. And I think this is important because the more you do it in repetition, the more you can remember it. So I'm just going to do that really quick. So first, the letters A, E, I, O. Then the statements. All P, R, D. Remember, I'm abbreviating policemen with P and donut eaters with D. All policemen are donut eaters. No P, R, D. No policemen are donut eaters. Some P, R, D. Some P, R, not D. I'm going to switch markers. The green one's kind of running out. All right, now I know I'm going to do quantity. How much of the subject are we talking about? Up here is universal. We're talking about the entire extension of the subject. All of them or none of them. Down here, we're talking about part of the subject. Some are not. Now I'm going to do quality. Are they affirming or denying something about the subject? Over here is the positive. All are, some are. So this is positive affirming. And over here is negative. No are, some are not. So this is negative. This is all we know so far. This is as far as we've gotten, but that's quite a bit. So today we're going to look at contradiction. Now, if you're looking at these statements, which of these at first thought do you think are in contradiction? Remember, contradiction is they have opposite truth values. They cannot both be true and they cannot both be false at the same time. So one has to be true and one has to be false. What the first inclination to think is the contradictory statements up here are all PRD and no PRD. They think those contradict, and then they think these contradict. Some are and some are not. However, that is not the case. And I'm going to change these up here just to show you. I'm going to do a clearly false statement up here so it's easier to tell. Because, I mean, people just think policemen eat donuts. So that, but I'm just kidding. We all know that. All right, I'm going to do one that's clearly not. Okay, all men are pilots. No men are pilots. Now this one, it might be easier to tell. All men are pilots. Is every man on the face of the earth a pilot? No. Are no men on the face of the earth pilots? That is false as well. So these are clearly both false. But our rule of contradiction says the statements cannot both be false. So these two are actually not contradictory statements. The contradictory statements are actually A and O, E and I. A and O contradict one another. E and I contradict one another. Now let's look at how we can see that this is true. All right, I'm going to change the subjects again up here I'm going to change the subject to students and the predicate to slackers. All right, so all students are slackers. And I'm going to come down here because this is the one we're looking at. Some students are not slackers. All right, so let's look at these two. All students are slackers. Some students are not slackers. If this statement is true, this one cannot be true. It has to be false, because if we're talking about the entire group, the universal group of students, and we're saying something about all of them are something, we cannot then say, and it be true, that some are not. So that's why these are in contradiction. If this is true, this has to be false. Let's flip it the other way. If it's true that some students are not slackers, if this is true, we know that all students are slackers has to be false. It cannot be true at the same time. So one is true, one is false. So that's A and O. Now let's look at E and I. No students are slackers. Some students are slackers. I'm just going to put S. Okay, so no students are slackers. Some students are slackers. We know if no students are slackers is true, so none of the students are slackers, we cannot then say truthfully that some are. So if this is true, this has to be false. If this is true, some students are slackers. If this is known to be true, you cannot then say no students are slackers, because we know it's true that some are. So this has to be false. So contradiction is opposite truth value. They cannot both be true, and they cannot both be false. Contradictory statements also cannot be consistent. If you remember back in our relationship of statements that do not necessarily, they're not categorical statements, they're just statements, there were relationships within that. That one had 4. And consistent means they can both be true at the same time. So a contradiction cannot both be true at the same time. So a contradiction is not a consistent relationship statement. So that is it for the contradiction. And if you notice here, we have added into our square of opposition a big X. Contradiction is an X. They cannot both be true or false at the same time. One is true, one is false. And the A and O are contradictory. E and I are contradictory, making a big X through our square of opposition. So that is it for contradiction. The next lesson, we will talk about contrariety, and then the one after that will be subcontrariety, then subimplication and superimplication. So I hope this has helped. Let me know if it has, or if something's still confusing, and have a great day, and see you again at a later video.